I'm Hyacinth Capino, and for this video, I will be discussing 3 problems in Chapter 26, which is about direct current circuits. So the first item is from problem 26.3, which is about resistors in series and parallel. The problem is, a resistor with a resistance R sub 1 is equal to 25.0 ohm is connected to a battery that has negligible internal resistance, and electrical energy is dissipated by R sub 1 at a rate of 36.0 watts. If a second resistor with R sub 2 is equal to 15.0 ohm is connected in series with R sub 1, what is the total rate at which electrical energy is dissipated by the two resistors? So the given R sub 1 is equal to 25.0 ohm, R sub 2 is equal to 15.0 ohm, and the original power is equal to 36.0 watts, the initial power. So we need to find the power after we have added the second resistor. Just a note that by changing the total resistance or by adding another resistor, we will be changing the rate at which electrical energy is dissipated, and therefore it means that there will be a change in the power. But this change will not affect the EMF, and therefore we will have a constant voltage. So in order to get the power after adding the resistor, we need to first find the total voltage. And to do this, we need to use the equation P is equal to V squared all over R, and we need to manipulate this equation in order to find the voltage. So the voltage will be equal to the square root of P multiplied by R, and we will be using the power or the initial power multiplied by the initial resistance. So that will be 36.0 watts multiplied by 25.0 ohm, and that will result to the square root of 900 volts, and that will be equal to 30.0 volts. Now, a second resistor is added in series, so that means that our total resistance will be equal to the sum of the first and the second resistor. So we have 25.0 ohm plus 15.0 ohm is equal to 40.0 ohm. So this will be our total resistance. So by using the equation that we used in finding the voltage, which is P is equal to V squared all over R total, we will have 30.0 volts squared all over 40.0 ohm, and that will be equal to 22.5 watts. So that is our final answer. So for the second problem, we have item 26.12, which is about resistors in a series and parallel, and this one is on the average difficulty. So the problem is, in figure E26.11, the battery has an EMF of 35.0 volts and negligible internal resistance, which is equal to R sub 1 is equal to 5.00 ohm. The current through R sub 1 is equal to 1.50 ampere, and the current through R sub 3 is equal to 4.50 ampere. What are the resistances of R sub 2 and R sub 3? Okay, so the given R sub 1 is equal to 5.00 ohm, I sub 1 is equal to 5.0 ampere, I sub 3 is equal to 4.50 ampere, and the EMF is equal to 3.0 volts. So we need to find the resistance of R sub 2 and R sub 3. In order to do this, we need to find first the voltage of resistor 1 and resistor 2. And since these two resistors are connected in parallel, it means that these two will obtain or will have the same value of voltage. So V sub 1 is equal to R sub 1 multiplied by I sub 1. R sub 1 is equal to 5.00 ohm and I sub 1 is equal to 1.50 ampere. So by multiplying these two, we will obtain a value of 7.50 volts, and this is the value for our resistor 1. And because, just like I said, resistor 1 and resistor 2 are connected in parallel, it means that the voltage of resistor 2 will also be equal to 7.50 volts. Next is we need to find the current of resistor 2. And in order to do this, we need to subtract the current of resistor 3 by the current of resistor 1. So 4.50 ampere minus 1.50 ampere is equal to 3.00 ampere. This is the current of our resistor 2. So since we now have the value of the voltage and current of resistor 1, we can easily solve for its resistance by using the equation R is equal to V over I, wherein V is the voltage and I is the current. So by substituting the values, we will obtain the value of the resistance of resistor 2, which is equal to 2.50 ohm. So the next thing is to find the voltage of resistor 3. And in order to do this, we need to subtract the total voltage by the voltage of resistor 1. So we have 35.0 volts minus 7.50 volts is equal to 27.5 volts. This is our voltage for the resistor 3. And since we already have the voltage and current for the resistor 3, we can already solve for its resistance. And we can do this by dividing 25.5 volts all over 4.50 ampere, and therefore our resistance for the resistor 3 is equal to 6.11 ohm. So that's it for our second problem. The third and last problem is from item 26.52, and this deals with power distribution systems. The heating element of an electric dryer is rated at 4.1 kilowatts when connected to a 240 volt line. Part A, what is the current in the heating element? Is the 12 gauge wire large enough to supply this current? And part B, what is the resistance of the dryer's heating element at its operation or operating temperature? Part C, at 11 cents per kilowatt hour, how much does it cost per hour to operate the dryer? The given P, or the power, is equal to 4,100 watts, and the voltage is equal to 150 volts. We are asked to find three things: the current, resistance, and the cost per hour. With the given, we can easily find the value of the current by dividing the power with the voltage. So 4,100 watts divided by 150 volts is equal to 17.1 ampere. And since a 12 gauge wire has a maximum safe current of 25 ampere, we can say that a 12 gauge wire is enough to supply this current. Next, we are asked to find the resistance, and to do this we need to use the equation P is equal to V squared all over R, and by manipulating the equation we will have R is equal to V squared over P, wherein V squared is the voltage and P is the power. By dividing the square of 240 volts by 4,100 watts, we will obtain the resistance, which is equal to 14 ohms. So for the last one, we are asked to find the cost per hour. So the dryer operates at 11 cents per kilowatt hour, and we are asked to find how much it costs for 1 hour. So we have 11 cents kilowatt hour multiplied by 1 hour multiplied by 4.1 kilowatt hour, and this will give us 45 cents. So it means that when you try to operate the dryer for 1 hour, it will cost 45 cents. So that's it. Again, thank you for your time, and if you have any question, feel free to email me at hyacinth_capino@dlsu.edu.ph. Be safe. Bye.